All right, so this is OpenEdge Database Performance and Resilience Tips 2022 edition. Hopefully I've updated enough things to make it worth your time, and presumably you're in the right room. If you're not in the right room, well, one of us is in the wrong room. I'm Tom Bascom, I'm with White Star Software. White Star Software, if you haven't already heard, we're a consulting organization. We mostly do database things with OpenEdge. We're completely devoted to OpenEdge. We don't like Oracle, we don't like SQL Server. We want OpenEdge, that's our world. And really all that much to say there. We also have this product called ProTop. ProTop is an OpenEdge focused monitoring and alerting tool. Tell you everything you want to know. It's really useful not just in your production database environment, but also in your development and QA process as well. We have a bunch of great features for that. Paul will talk about them later today. Tomorrow, sorry, it's tomorrow, not today. I'm Tom Bascom, as I mentioned. I'm a really sketchy coder. As we saw in my workshop this morning, I can write some really bad code. Some of you experience that, some of you may experience it tomorrow morning. It's actually very difficult to write bad code that does a bad thing in a very special way. It's easy to write bad code when you don't mean to. It's harder to do it when you're doing it on purpose. But anyway, enough of that foolishness. We'll get on to the database side of things here. So, my number one tip, which my colleague Rob talked about this morning, is to stay current. Don't let your OpenEdge release become 10 years old. That's really not where you want to be. You don't necessarily need to be on the bleeding edge, but you do want to have an up-to-date release of progress, your operating system, and your application. When you're running a really, really old release, you expose yourself to a lot of problems. In particular, you expose yourself to a lot of security problems because, as you know, the security landscape changes very rapidly, and it often requires updates and patches and things like that in order to stay up to date. And if you're running a really far behind release where you're not getting patches, where you're not getting bug fixes, your security situation is worse and worse and worse as time goes on. So you really can't drag your feet like you were able to in the old days. Now this is a primarily European audience. Some of the online people may be from North America. The Europeans are usually more up to date. You're less likely to be running something ancient and old, but everybody really needs to stay relatively up to date these days. The next tip is type 2 storage areas. Is anybody not running type 2 storage areas? Can I retire this tip? Anybody want to volunteer and say I'm only type 1? Okay, good, excellent. But anyway, just in case, type 2 storage areas are the foundation of all the modern features of the database. So every new thing that Progress releases, every cool feature, pretty much requires type 2 storage areas. If you don't have a cluster size of 512, 64 or 8, then you're type 1 storage area. And that's really bad for a lot of reasons. It's bad for performance, it's bad for the functionality of the database. You don't want to be doing that. The schema area, unfortunately, is a type 1 area. So if you are, by default, putting your objects in the schema area, you're getting stuck with a type 1 area, which is another thing we found out in the workshop this morning was not such a great idea. No application data should ever be in the schema area. Only the schema should be in the schema area. So if you haven't moved your application data out of the schema area and into type 2 areas, go home, take care of that, come back next year, tell us how good it went. If you think you have a really good legitimate exception for that, please submit a presentation for next year. We'd love to see it. So far, nobody's taken me up on this one. Okay. Moving past that, the next really important performance kind of a tip is the buffer cache, the big B buffer cache. This is how you use the memory in your system, and systems have more and more memory year over year over year, so you have an opportunity to grow, to avoid I/O. That's really what it's all about. It's about avoiding the disk I/O operations. And the efficiency of big B is really related to the hit ratio. which is how frequently a piece of data that you need is in memory versus on disk. The higher the hit ratio, or hit percentage, the less likely you are to be reading disk, and the faster it is for the user. And if you look at this chart over here, whoops, this chart over here is basically showing you how that affects performance. So when you have a really low hit ratio, you have a lot of reads. As you increase the amount of memory, the number of reads goes down, and it's an inverse square relationship. So you take the size of the buffer pool, and you take the square root of that, and that's how many I/O ops you should expect to have, more or less, kind of, sort of. It does pretty much work like that. And the cost of those read operations, or write operations, either one, is quite high. So if you're doing a lot of I/O operations, and each one of them is relatively slow, very painful to the user. As you reduce that, you're doing far fewer of those operations, and that pain has gone away. So you really want to have a nice high value of big B. And to improve the hit ratio, though, because of that inverse square relationship, you need to make big increases. You can't just change it by 5 or 10%. You got to double it or multiply it by 10 or something like that. You can't make a small change and expect to have much of an impact. Currently, I have a customer who's running with their buffer cache at 12.5 million. That's 100 gigabytes. That's a lot of memory, but that is an actual legitimate value for the buffer pool. Mike, do you have any bigger ones out there?
We have one, 128.
128?
I don't anymore.
Wow, you used to have one. Yeah, so you can have some very substantial values for the buffer pool, and it's perfectly legitimate. It used to be people were worried about having more than a gigabyte of RAM, but RAM has really become much more available in the past, I don't know, 5-10 years. Here's an old slide. This is from some testing that I did longer ago than I would like to remember. But it's basically comparing the cost of accessing data between different layers of your architecture. So the cheapest cost is going to be when the 4GL session is accessing data directly in the buffer cache, and we're going to call that 1. And the cost per operation here was very, very low. Is that microseconds or nanoseconds? I'm not sure which. Yeah, it looks like microseconds. The minute you move the data out of the buffer pool into the file system cache, it becomes tremendously more expensive, 75 times more expensive to get that data, even though it's still in RAM, out of the operating system. So you really, really, really want to bring it in where the application can use it directly. And then as you move out to a SAN, or you go, this is the cache on the SAN versus the disk on the SAN, you're having a bigger and bigger impact on the performance that the users are going to see. So move your data into memory. Yes, Gus?
Left out one.
What did I leave out?
When your buffer pool is paged out.
Okay, true. You don't want to make your buffer pool so large that it gets paged out. That is kind of a problem. You would want to avoid that. Was there a question in the back?
I just wanted to ask if you can repeat the question that Scott was going to give so the online stream can hear it as well.
Okay, yes. So the question was about paging out the buffer pool, in case anybody missed that. All right, so next one. Spin. So there's a parameter called spin. Once you've eliminated your I/O, you're likely to become bound on CPU because you don't have network and disk I/O holding you back. So now you've got to look at how the CPUs are behaving. What the spin is an algorithm that basically, instead of going to sleep when progress needs to share a resource, it sits there on the CPU and says, can I have it, can I have it, can I have it, can I have it? And while I'm saying that, Rob's saying that. Can I have it? Can I have it? Can I have it? And we're all competing in this looping sort of a fashion. Eventually, one or the other of us gets the resource, and we're able to move along. A lock is taken as shared memory. It's called mutex lock. If you remember your college days, you probably studied this kind of stuff. And it's more efficient than sleeping. although it does use a little bit of CPU. You can get carried away. If you make spin too high, then you're going to spin and consume CPU more than you would have napped. So there's a balance that you want to reach there. In my experience, typically some relatively modest values work for most people most of the time. There's always exceptions. You always have to keep in mind that you might have a different situation than most people most of the time, but 10 to 20,000 is usually pretty good. The default is to take the number of CPUs in your server and multiply it by either 6,000 or 3,000. I think it depends on the, I think there's a variation there depending on the version of progress. But anyway, you can get some very high values for spin because of that default behavior. So you probably want to set it instead of allowing it to set itself. Rich Banville did a great presentation in 2008. That was a long time ago, but it was a really good presentation on how to look at spin and what some of the differences that you could get are there.
Tom, can I make one comment on this that you want to repeat?
Yes, Mike, use the microphone though so the people online can hear you.
Hello?
Is it turned on?
I turned it on. If you don't have it set and it's set to, I don't know, 180,000,
Yeah.
be careful dropping it from 180,000 down to 20,000. I think you should give the same advice as Dash Big B. Cut it in half.
Yeah.
Let it ride for a little while. Cut it in half, let it ride until you get to the value here. We've had experience where people were at 96,000 because they didn't set it on, and it was defined by the number of CPUs. We came, cut it down to 20,000. They forgot that they did it. They rebooted 6 months later and had big problems then.
Okay, that's reasonable. So basically Mike's saying take it in steps. Don't just go from a really big value to a really small value. Go down in increments. Half it, something like that. If you've been to some of the other presentations, you've seen quite a few of us don't like NUMA. There's a theme here. This is some testing. NUMA's good for consulting business. It's not good for your database's production performance. NUMA is basically, if you have a large server with a lot of cores, it's almost certainly a NUMA server. Because you can only get about 8 cores into a single CPU chip, so anything that's got more than that going on is probably a NUMA chip. And the faster the cores are, the fewer of them will fit into a chip. So if you have slow cores, so you've got maybe a 2 gigahertz clock speed, then you might have 12 or 16 or 24 cores in a single chip. If you have fast cores that are going at 3 or 3.5 gigahertz, something like that, then you probably only have 6 or 8 of them. That's the trade-off that you make in server purchasing. Anyway, this particular chart is some testing of the impact of different scenarios of record reads per second in a NUMA scenario. So in the default situation with 4 nodes, so that's 32 cores, 8 cores per CPU, 4 nodes, so 32. We're getting about 1.25 million records per second. That's just default configuration. Then we tried various improvements, but the best performance was when we had just 1 node active. So basically disable 24 cores. That's really exactly what I did. I disabled them. And the performance at that point was almost 3 million records per second, 3 times higher at that point. Here, we added 1 extra CPU, just 1 core, fell off a cliff. You're getting half the performance at that point. So you really get a big benefit from just using the 1 node. The other thing about this, I don't have a chart for it, is that if you're looking at the CPU consumption, no matter how hard you push the server, you're never going to use more than effectively 1 core's worth of CPU time. You have all this unused CPU, you're pushing it as hard as it can, it won't go any faster, so it looks like you have unused CPU time, but you can't make it go any faster. So you might as well shut them off anyway. When you shut them off, you'll be using 100%, but you're using 100% of a quarter of what you had before. So it's effectively the same CPU utilization, except it's more efficient. And one of the reasons it's more efficient is because you're not having the memory stalls. So if you think about how a CPU operates, when it needs memory, far memory, and it has to wait for it, then the pipeline stalls. So the number of instructions being executed per cycle is reduced, and the effectiveness of the CPU utilization that you're demanding becomes less. So bring it in, shut off the stuff you don't want, it'll go a lot faster. The accountants won't like it very much because they'll realize they wasted money on CPUs that aren't doing anything, but the users will be very happy because things move much better. So the conclusion, NUMA's poison, stay away from it, disable it if you can. You can't avoid buying it because that's all you can buy these days, but try to rein it in. Any questions on that? LRU skips. Yes.
You mentioned NUMA control on a previous slide, but you can also find out about NUMA on a Windows machine by looking in Task Manager.
So Gus is pointing out that you don't have to use NUMA control. If you're on Windows, you can use Task Manager to get information about NUMA. That's true. My example was a Linux example, not a Windows example. But you have the same basic result either way. Anything else? Okay, LRU skips. So this is a parameter that was introduced back in 10.2b. It was not a default, so the default was for it not to be set until OpenEdge 12. With OpenEdge 12, it is now defaulting to 100. So you get the benefit of this parameter. If you're still on 11, you want to make sure that you have LRU skips running. A big part of the, you remember the slides from a couple years ago when OpenEdge 12 came out and how much faster it is? A big part of that was enabling some default parameters like LRU skips to support that. LRU skips 100 is very good for most people most of the time. However, you might, if you have a very large big B like we were talking about earlier, want to consider some slightly higher values. You don't want to linearly scale it. You don't want to say, oh wow, I'm using a big B of 1 million, so 10 million would be 10 times higher. But turn the knob up slowly but surely. It may help you. I found it somewhat helpful for transactional things as opposed to reading. It does seem to have an impact there. The metric that you might see change is the DB buffer share lock resource weights, not the LRU, not the latch weights, but the resource weights. Another tip for you is to set the range sizes. So if you have a busy system with a lot of stuff going on, one of the things that you really want to know is where is that activity? What tables, what indexes are being used by the application, and is that an appropriate usage for what I expect the application to be doing? Well, you can't really see that unless you have the table range sizes and the index range sizes set large enough to capture the metrics that go with that. The default is to only capture 50 tables and 50 indexes, which is not enough for the sports database. So a real production database almost always has more tables and more indexes than that. So you want to set a larger value that you can capture all those statistics. Starting with 12, you can use increase 2 to increase it online. So you don't have to take the database down and restart it to enable the table and index range sizes, which is really wonderful. And if you run ProTop, we'll even generate a PF file for you just in case you need a little bit of help. Okay? Other ARGs. Anybody use OpenEdge Explorer to manage their database? Oh, I was about to say nobody, great, but no such luck. Okay, so if you're using OpenEdge Explorer, and you have conmanager.properties, and you're setting all your properties in there. There's a lot of stuff that you can't actually set in OpenEdge Explorer. So you need to use other args to specify it. And what you can do is you can put a PF file in there, and that way you can make your parameter changes without having to start Explorer and take the risk that, oh, it accidentally set the hash value for you or something like that. You can just change them in the PF file. And then you can use dbman to start and stop things and never have to go to that horrible OpenEdge Explorer UI, which is great. I personally never use OpenEdge Explorer. Rapid readers. So a very common application pattern is that you have certain bits of code that frequently access some very small tables. So once you have your table range size and your index range size enabled, what you'll see is that there are some tables that are very, very busy. And they may not be the tables that you expect to be busy. If your application is primarily concerned with moving things around in a warehouse, you would think that the tables that are associated with the inventory and orders coming in and all that kind of stuff would be where you see your action. But you often find out that your action is in some system control tables that only have a few records in them. So you have this very small table. It'll have 10 or 20 records or 100 records or something like that in it, but you'll be reading it millions and millions and millions of times, over and over and over. And that table is going to be in memory, because the whole point of the memory is to buffer things that are frequently used. And that means that you're going to have a lot of latch contention for that table. And those rapid readers, those tables that are being turned over and over and over again, are an opportunity for you to make some coding improvements. Sometimes what you'll see is that the table is effectively a read-only table. And what you can do is you can cache it. You can read it from the database. When your session starts up, you can put it in a temp table, and then you can use that temp table throughout your session, and you'll never read it again. You'll never have the contention in memory. It's a very simple thing to do. If you need to, you can put a timeout on that cache. You can say, just read it once an hour or something like that, or maybe once every 10 minutes if it changes that frequently. But a lot of them really are read-only tables, and you really only need to read them at startup. And you can read them again tomorrow when people start up again. Or you might have a really bad where clause. So maybe you're, and we found this in the workshop this morning, maybe you have a common lookup. Maybe you're looking things up by name, but there's no index on name. Well, guess what that means? That means you're going to have a table scan. And if you have a table scan when you're only trying to get one record, you're doing a lot of work you don't need to be doing. And that's going to slow things down too. proGetStack. So if you're ever wondering what your code is doing, one of the ways you can find out is you can run proGetStack with a process ID. And what that'll do is it'll generate a 4GL stack trace of that session, which is great because it tells you what line of code and what procedure is running. The nice thing about proGetStack versus the client statement cache is that it is not dependent on what database statement was last run. This is what the 4GL session is doing right now. So this piece of code isn't necessarily a database-oriented statement. It could be a do loop or something like that. And this is great. You run it a couple of times to make sure that you're in the same code consistently, and then you can go and you can look at that code and you can make some performance improvements. It's really nice. Anybody use this? Okay, so we got some. Anybody not use it? Okay, so it's news to at least a few of you. That's good. You should always start an AIW, a BIW, and a watchdog, and an APW. These are the helper processes. What they do is they do I/O on behalf of the end user. So instead of the end user having to wait for a disk write, the helper process will do that for them asynchronously. That's what the A is, that's asynchronous page writer. You can only have one BIW, one AIW, one watchdog. You can have multiple APWs, but you generally don't need more than one. If you feel like it, go ahead and start 2. But you don't need to be starting 30 or 40 or something like that. There's, as we talked about this morning, there are some really old K-base entries out there that say you need 1 for every disk that your system has. And that was true 20, 30 years ago when you had discrete disks. But now you've got these SANs that do all that behind the scenes. You don't want to count those disks and start APWs for each one of them. That's not necessary. It's not helpful. 1 or 2, that's all you need. If you do see that you're consistently flushing buffers at checkpoint, then yeah, you might want to increase the BI cluster size and add an APW. But you probably aren't going to see that. That doesn't happen very often, and it's not something that you want to try to proactively anticipate being a problem. There are some miscellaneous PROUtil commands that are pretty handy to know. So truncate BI, set your BI cluster size to something bigger than the default. 16,384 is a pretty good starting place if you don't have anything better to pick. I usually actually do 65,536 because I like powers of 2. You want your block size for both the AI and the BI to be 16, not the defaults. Large files are now the default. Large files and large keys, OpenEdge 12 takes care of that. But if you're doing something with an older database, you might need to set those. Anytime you do an update or a version change, then you want to do an update schema and an update VST. If you create a new database, it's a good idea to grow a couple of BI clusters ahead of time so that you don't have to do that when the users come in. Do that ahead of time for them. And then this increase 2, if you make a mistake with a parameter and you don't want to shut down the database and start it again, you can temporarily increase certain parameters like the -b parameter and OM size and the lock table and various things like that. So that's a capability that you can do online. ProBKUP. This is the one and only approved way to back up a ProRGS database. You don't want to be doing SAN snapshots or VMware, vMotion kinds of things. Those are great ways to need to freshen up your resume and get out there on the job market. If you want your backups to be able to be restored and to have all your data, you want to use ProBKUP. The BP10 avoids the ProBKUP flushing the entire buffer pool when it reads it. So that basically is saying use private buffers, just 10 of them, and that way you don't read everything into the buffer pool and flush everything that is being cached in the buffer pool back out onto disk. You don't want to do that. The nice thing about ProBKUP is that it knows where all the pieces of the database are. So particularly if you have an older database that you have added extents to over time, maybe because the database has been growing, a lot of times some of those extents get added in weird places. You may have started out with a nice structure with everything in the DB file system. And then one day you needed to add 100 gigabytes somewhere and you didn't have 100 gigabytes on your DB file system, so you put it over in /u/special, and then you forget. And you're making an operating system backup, and then you go to restore it, and you're missing 100 gigabytes of data. That's a really unpleasant situation to be in. So you want to use ProBKUP to avoid that, because ProBKUP knows exactly where everything is. You don't have to tell it anything. Some of the ways that you can get fired, if anybody's looking for any suggestions. These are all terrible things to do. And a couple of times a year, we have people who have problems where they can't recover their database because they were doing backups in an unapproved manner. And there's nothing you can do to help them. Sorry, your data, you didn't back it up. I can't help you with that. One thing to watch out for is deleting old backups before you have the new one ready. So a lot of really old scripts, if you have some stuff that you've been working with forever, it creates the backup on disk by overwriting yesterday's. You don't really want to do that because as soon as you start that overwrite, yesterday's backup is gone. You can't recover at that point. So however long it takes you to make that backup, you have a risk of data loss at that point. You don't want to be in that position. So always create a new file for your backup, and then once the backup is complete and you're happy with it, that's when you want to delete the old backup or archive it or do whatever you're going to do with it. But don't overwrite it immediately, and especially don't do that with Windows, because Windows really hates overwriting those big files. It's very slow sometimes, which I think, yeah, actually, Windows doesn't like doing that at all. So third-party tools, I think I already covered this really. One thing to watch out for, if you're on Windows and you're using a task scheduler kind of a job to do your backups or other administrative things, you need to make sure that that user never logs in. Because Windows has this nice little feature where if a user ID logs in and then logs out, at logout, Windows will go and find all the sessions that belong to that user and kill them, even if they were started by Task Scheduler. That's not very helpful. And if you were holding a latch at that point, you're going to crash the database too, which is one of the biggest sources of Windows database crashes that we have to deal with, is people logged into the server, somebody logged something out, and a background job got killed, and that brought down the database. Happens quite a bit. Gives Windows a bad name. Not that I'm here to rehabilitate Windows or anything, but it does give Windows a bad name. SQL. Anybody use SQL? Nobody? Oh, darn. Hands went up just as I was about to move on. Okay, so SQL is a little bit different from the OpenEdge 4GL. It has a different set of assumptions. In particular, SQL likes to think that the field width is important for some reason. I don't know why. Progress showed them the way back in the 80s, but none of the SQL vendors understood the importance of variable length fields, so life is really rough. SQL is also not necessarily well configured in an OpenEdge database. It doesn't get a lot of care and attention, and there's a lot of opportunities to make it better. If you don't know, maybe you inherited a database that has SQL in it. The default DBA is, sysprogress. And if you don't know what the SQL login is, it's worth giving a try to sysprogress with a password of sysprogress. It works about half the time. Security tip for you. You might want to change that password if you're using it. If you need to test things with SQL, the SQL Explorer tool is provided by Progress. It's always available. So this makes it really, really easy to start a SQL client, run some test code, like select count star from pub.customer, and see whether or not your configuration is set up the way you think it is. So that's kind of how that would be. Particularly if people are calling you up and saying, hey, I can't get connected to SQL, you can say, well, it's not because the database isn't letting you. It's because your tooling isn't correct. Maybe your client hasn't been set up right. Maybe your DSNs need to be configured. As I mentioned, the SQL width issue has been kind of hounding Progress for years. There's a tool, it's called dbtool, that you can use to scan the database and expand that width so that SQL tools can deal with the data. Anybody ever have this problem? Most of you. I've always wanted to say that. Later. dbtool is one of the ways that you can fix it, but it's not the only way. Starting with 11.4, Progress introduced a bunch of database startup parameters and options that will autonomously make this change. So it'll do it continuously through the day. And there's a couple of different ways it can work. One is that when you read the data, then Progress can just truncate it to whatever the defined width is. And so the SQL client thinks that the 30-character field was only 30 characters, even though you stuffed 800 characters into it. That's one way to do it, maybe not the best way. You want to be careful when you do that, though. You want to only do that you probably only want to do that truncation on output, which means when the data is returned to the client. If you do it all the time, then what's going to happen is that's going to affect the where clause. And so if the field is too wide for the where clause, then the record will be rejected, which is probably not the behavior that you want. So output is usually the parameter that you want. You can also automatically update the width. So when it finds a field that's too wide, it can automatically update that in the schema, and then it won't be a problem the next time around. If you use that, the SQL width update, then you don't have to do dbtool anymore. So you don't have to periodically run dbtool.
Can you combine it?
Yes, you can have both at the same time. The question was, can you combine those?
If I remember correctly, when you turn on SQL with update, it automatically turns on SQL truncate too large, or the opposite, I get it backwards.
So,
SQL width requires SQL truncate.
so the guys are saying that SQL width implies or requires truncate to be on. So, yeah.
But if you don't set it, then in 11 dot whatever, it'll set it to on, which will screw up your where clauses, so you should use both.
Right, because right. So the point there is if you're allowing it to be automatically set, you're going to get on, which is the behavior you don't want, you want output. So it's better to explicitly put the parameters in there so that you don't have that behavior. Yes?
That's database startup.
That's a database startup parameter, yes. Yep. Broker startup parameter, to be more pedantic. Also with SQL, you need statistics. SQL uses a cost-based optimizer, unlike the 4GL's rule-based optimizer. So the 4GL figures out which index to use based on what's in the where clause, and it goes through an algorithm and picks the index, and that's the index it's going to use unless your code explicitly overrides that. SQL, on the other hand, looks at the data distribution and picks an index based on that. But it can't look at the data distribution unless it has some data about it. It has to have those statistics generated in order to do that. So you have to occasionally run update statistics to feed the optimizer information about how to make good choices. Wow, that's kind of interesting. Periodically, how do you know how often to do that? Well, the usual advice has been when 20% of your data has changed. Well, how do you know that 20% of your data has changed? You don't. This is pretty hard to do. So usually what happens is you run it quarterly or monthly or something like that. There are some new features coming down the pike. I think they're in the innovation releases, though, to automate this. I don't think this is in 12.2 yet. 12.5 or so? Yeah. So for now, you still have to do the update statistics kind of stuff. And here's a little program, a 4GL program, to create a SQL program, in case you need it.
It's in 12.0.
It is in 12.0?
Yes, sir.
Wow. Okay. All right, I'm behind the times. Sorry. I didn't know that. I really thought it was later than that. Index compact. So a frequent problem that you'll have is that you run a big purge process and maybe you only do this annually or quarterly or something like that. You delete a bunch of records out of a table. And then the indexes are not terribly efficiently broken out on disk. You can run index compact online to bring them together and to make the index take up less space. Less space means fewer I/O operations and better use of the efficiency of the memory. So when you read stuff in, you have more index entries in the block that you read in, so you do fewer reads. Fewer reads is always better. So you can run an index compact. So you look at the DB analysis data, look at the number of blocks that each index is taking, and the utilization. So if you have a large number of blocks, and 89% is actually pretty good, and a poor utilization, then that's a candidate for an index compact. So usually the advice we give people is if there's more than 1,000 blocks, your utilization is less than 70 or so. That's an index you might want to compact. You can run it online. It's perfectly safe to do. Don't set the target optimization to 100%. That's not a good idea because the first thing that'll happen is you'll be doing block splits right away. It sort of defeats the whole purpose of it. You know, set it to 80 or 90 maybe, but don't set it to 100. That would be counterproductive. Remote connections. So we used to always tell people use the shared memory connection because the shared memory connection is faster. And it is. However, it's becoming increasingly difficult to advise people to always use the shared memory connection for several reasons. A lot of applications are just client-server by nature. You've got a Windows client and a Unix backend. You can't use a shared memory connection there. You're using PAS-OE, and Progress's strategy with some of the PAS-OE features is to be able to run them in a container so you can start and stop containers when there's problems with the PAS-OE. Well, you can't do that in a shared memory environment. You have to use a remote connection for that. Progress has done a lot of work on improving the the client-server protocol and introduced a whole bunch of parameters quite a while ago, actually, to support the prefetch optimizations, as well as the server-side joins and multi-threaded servers. So your TCP/IP connections are much faster than they used to be, as long as the data access is something that is a query, which is a for each no lock. So that's different than a find statement. A find statement is always going to read a record, it's going to make a request, it's going to get a response, and it's going to acknowledge that. So there's always going to be 3 messages per record, bang, 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 back and forth with find statements. But with a for each, Progress can take and bundle up those records and put them in a big message and send you a whole bunch of data all at once. And that's great, that's really fast. A lot less motion in the ocean there. So you want to have a pretty large message size. 8,000 or larger is pretty good for that. You want to spread connections around and use the multi-threaded servers if you can. And then in your code, if you can use a fields list and not send data that you don't need. So maybe you're doing a customer query and you just need a list of customers. Well, you don't need to know what state that customer is in. You don't need to get their picture out of the lob that has their picture in it. You don't need to know what their zip code is. You just need their name. So in the fields list, you specify, I just want the name. That means that even more data can be packed into that message. So that makes it that much more efficient. Keep in mind, in where clauses, that the can do statement is evaluated on the client, because can do is not a string manipulation function. No matter how much bad code from the 80s you may have seen, can do is a security function. It is not a string function. It's evaluated on the client, which means all the data has to go over to the client to be selected and worked with. You don't want to do that. That's going to slow you down. It also has all sorts of hidden features that are somewhat unpleasant. If you can use no auto result list and do forward only queries, so you don't have to scroll back and forth in the queries, that'll improve the performance of those. And use a large number of prefetch records. So you've got this big message size, you want to stuff as many records as you can into it. The default to OpenEdge 12 was 16 records. 16 is a very small number of records, so set it to 1,000 or higher, depending on the nature of your data. And here's some stuff about the impact of various parameters. And what we see here is that the biggest impact was to set the number of records very, very large. You got some improvements as you came along, but really what happened was the big improvements came from the prefetch numRecs. And I'm coming up on time. Ooh, I'm nowhere near done. Okay, beware of virtualization. Virtualization is not magic any more than NUMA is. People will sell you it, but it's not going to make your system go any faster just because it's virtual. Okay, we'll skip over that. So this kind of ties into the NUMA talk. Don't go out and buy the biggest machine that you possibly can just because you have the budget for it. You'll find that by right-sizing your environment, you can save money and improve performance at the same time. There actually is a Santa Claus. If you don't go out and buy too much hardware and thus span that NUMA gap, do things that are going to cause those extra cores to get used, or cause scheduling problems inside of a virtual host, you'll get better performance. You spend less money, get better performance. Same with your disk. Internal solid-state disk is always going to be faster than a SAN. There's no such thing as a high-performance SAN. There's no such thing as a cheap SAN either. There are cheap internal solid-state disks. Now, there's a trade-off there. You have more management to do. You have to think about your systems a little bit differently, but I don't know, it's not that hard. So here's the SAN scam. Just in case if the salesman's lips are moving, he's lying. This is the key thing, the speed of light. It's only 30 centimeters per nanosecond. So the further away that SAN is from your CPUs, the slower it's going to be. And oh, by the way, the speed of light in glass is only about 2/3 of the speed of light in vacuum. So it's even worse. Okay, RAID 5, yeah. Okay. Temp file I/O. How am I doing on time? Am I out? You're over. I'm over? Okay. Well, I don't see anybody running for the door. So. I'm only about halfway through, you know. I thought I was going fast. Temp file I/O. It's not just the database. It's progress. Okay, they're putting us out of here. It's progress. It's an application. Temp files have I/O too. You need to manage that from the client side. So there are some parameters that you can use. -T is one of them. You can also get information about what's happening in your temp files. There's a whole class that you can implement. We've got some sample code in ProTop that you can look at to see what you are doing in your application with your temp tables. So you can get like this kind of information. This is like the DB analysis, but for temp tables, which is kind of cool if you can do that. Free code, download it, have fun with it. Yeah, okay. Strive for 5 nines. All right, I'm afraid I'm being chopped here, so sorry guys. I didn't cut it down to 45 minutes after all. Huh? A lot.